Michael, we are on 1-8 notes. This is example 4. They start us off with evaluating a difference quotient. Okay, and this is the formula that we have to do for evaluating a difference quotient. You don't need to know this, but this has a trig or a calculus application to it. So this formula is what we use to calculate limits and stuff. We're just plugging stuff in when we're finding f of x plus h and all that good stuff, okay? So the first thing they want us to do, here's your formula. 3x minus 5, that's what we're starting with, which is a linear function, right? Linear function. Shh. Here we go. We are taking and we're finding f of x plus h, and this just means we're taking x plus h and we're plopping it in where the x was. Got it? So we have 3 times x plus h minus 5. We're just taking and replacing this x with x plus h, and then we're simplifying, and that's all we're doing, right? That's what f of x plus h means. Simplify, we get 3x plus 3h minus 5, and that is all we can do. Okay? Got it? Do you see how that works?
Yeah.
Okay, the next thing says find the entire difference quotient. We have already done this part right here. Do you see that? F of x plus h? We just did that. That is this thing. He's going to go right there. So on the top, I have 3x plus 3h minus 5. That is done for us. We already did that in part A. Got it?
Where did your Kleenex go?
I don't know. Okay, minus f of x. That's the next part. What is f of x, by the way? F of x is just 3x minus 5. So I'm going to plop him in his spot right here. Minus 3x minus 5. Do you see that? We've already done this chunk. We've already done this chunk. Now we're doing minus f of x. And we have all that. All over top of h. Now, I'm going to tell you to be careful because of what?
You have to
Distribute the minus sign through, okay? So I've got 3x plus 3h minus 5 minus 3x plus 5. And there's going to be lots of magical stuff that goes away. All over h, okay? You calc kids, you be ready. 3x minus 3x minus 5 plus 5 equals, what do you get? 3h over h, which is 3. What did we just find, calc kids? The derivative. Ridiculous, right? We found the derivative of 3x minus 5. Is that the derivative of 3x minus 5? Yeah, look at that. Okay? So, that's just plopping in and doing what they want us to do. f of x plus h minus f of x all over h, and simplify. That's all they're wanting us to do. Okay? This has a meaning for calculus when we get to that, but now you know how to plop stuff in, okay? We got to practice plopping stuff in, okay? Next, this is going to be very much a little bit uglier, okay? All right, so be prepared. Here we go. Here we have 2 x's. We've got an x squared here and an x here. And f of x plus h means x plus h goes in that spot, right? So negative 2, x plus h goes here, squared, plus 4 times x plus h. This is going to be very much uglier.
With the product or the power?
Okay, do you guys see what I just did? Plopping x plus h in there. Okay, now, we've got to do this chunk first. Let's do x plus h squared. If you're taking x plus h squared, that is x plus h times x plus h. You've got to FOIL it. Okay, let's FOIL over here. X times x is x squared. What's x times h? xh. Then I've got another xh right here, or hx, which means the same thing, and then plus h squared. Okay, so now I've got that thing, x squared plus 2xh plus h squared. Okay, now before, you see where I get that information from? Before I plop him in here, what do I have to do with him? Or put him in this spot? I'm going to distribute the minus 2 through. Okay, can I do that? Distribute the minus 2. So, negative 2x squared minus 4xh minus 2h squared. Do you see where I got that? Yeah? That's what this part is. Good? All right, next, this part. We're going to distribute the 4 through. So plus 4x plus 4h, and then I've got the minus 1 on the end there. Do you see what I just did? That's that whole big chunk, and nothing consolidates. Nothing goes together, right? That is all of that piece, okay? Find the entire difference quotient. So we've got f of x plus h. That junk is all going to go. I'm not going to rewrite it. Can I just leave it there? And then we just do this next part minus f of x. Okay? So I left it in that spot. F of x plus h is that junk that we just got into doing. Minus f of x, which is this guy. Negative 2x squared plus 4x minus 1. You see where we're getting this stuff from? Anybody have any questions? Where it comes from?
Just do the plus and negative.
All over?
H.
All over h. Okay? All right. This is going to become plus. This is going to become minus. And this is going to become plus 1. Right? Can we consolidate stuff now?
Yeah.
Don't think we-
I'm trying to refrain from having to like write this like 4 times.
The
Okay?
X squareds.
The x squareds cancel. Negative 2x squared plus 2x squared. Gone. 4x and minus 4x. Gone. Minus 1 plus 1. Gone. So on the top I have negative 4xh minus 2h squared plus 4h all over
Wait, how do you get
h.
4? Isn't it 2? How do you get 4?
Right here? This 4?
No, first
It was
4.
2xh.
This first 4 right here?
Yeah.
It was 2xh right here, and then we have to distribute a 4 through, or a 2 through.
Oh, I
Okay.
didn't know 2x.
This is like in a silly, goofy mood.
All right. Are we good to this point?
Mood ever.
Jose, shh. Are we good to this point?
It's just a lot of work.
It is a lot of work. Okay? Now let's do this. Out of the top. Those 3 terms on the top.
2 and an 8.
Take out a just gonna take out an h. Just real quick. Because he cancels with the bottom. That's the only thing he cancels. So I've got minus 4x minus 2h plus 4 all over h. And then the h's cancel. And this is all that I have. Negative 4x minus 2h plus 4. Okay, calc kids, I still have h's in my answer. Do you know what happens now?
Plug it 0, right?
Yeah, this is the limit as h goes to 0 of that junk, right? If I plug 0 in, I get negative 4x minus 2 times 0 plus 4.
Do we need to know this?
This goes away,
No.
right? And your derivative is negative 4x plus 4, yeah?
Do we even
Could
need
you
to know
have
this?
just used the power rule?
Don't tell me.
Is this the derivative, negative 4x plus 4?
We could have.
We totally could have.
Don't tell me.
This is finding the limit or finding the derivative the longhand way. You remember doing the longhand way? Okay? All right, you guys don't need to know that for now. But this is plugging stuff in. Got it? That's the difference quotient.
Homie,
Something called the difference quotient. What?
can us calc kids just do the power
No.
rule? Would that work every
No.
time?
No, because you're not finding the derivative. You're just doing the difference quotient.
It's the same thing though. Because we did
Okay.
that and we let you talk
Moving on.
the entire time.
Sure. Sure. Moving on. Okay. Next thing. This is called a composite function. Okay? Composite means one stuck inside of the other. Right? Composite functions. Okay? When I teach composite functions to my Algebra 2 kids, are you ready for this? I always start with this. Let's say you have an item that is 50% off, and then you have a 50% coupon.
Should be free,
Okay?
right?
It should be free, right?
No.
If I have something that's $100, let's start with $100, and I am taking 50% off, that is now going to be $50. Then I apply a 50% coupon,
It's $25.
and now it's going to be $25. It's not
What
free.
happens if you have
So
another 50?
the way that this works, then it would be like $12.50, and then it would be $6.25, and then it would be $3.13
It would never
or
go
whatever
to
it is,
zero,
right?
right?
And never goes to zero.
Yeah.
Right.
Try again.
So the way that this works is that you are not adding the coupons together. You are sticking one inside of one operation, which is 50%. Then that answer is getting stuck inside of another one. Okay. So here's your example. F composed of g of x. This guy right here. This is called F composed of g of 6, technically here. Fog is the same thing as this parenthesis. You can write it with parentheses or you can write it as fog. It doesn't matter, right? Fog means the same thing as F parentheses g of x. Notice that this is not multiplication. We're not taking F times g. This is composition. The g of x is stuck inside of the F. Like x would normally be here, g of x is stuck inside of there. Got it? This is F composed of g of x. So when we do this, we're going to work from the inside out. So we're going to start with g of x, okay, or g of 6. If I evaluate g of 6, that means I'm sticking 6 into g. 6 minus 4, so g of 6 is 2. This guy right here is 2. Now,
4.
we have to find f of 2. Do you see how this works?
Wait,
So the first operation, the g of 6 is like finding my sale value. Then I'm taking that and I am, what?
6 minus 4, Ellie.
I plugged it into the g. Yes, ma'am. Pause. Okay. So, yeah.
Oh, I remember this.
Yeah. Okay. This is like me doing the
do
sale
one
price
and
and then the coupon to that answer, right? So 2 was the sale price and now I'm going to do the coupon to that, right? Okay. So f of 2. Can I unpause? Are we good? Okay. So 2 squared plus 2 times 2, what's that? 8. Now we're to 8. Okay. So that's that answer. All right. Good. To do B, this is g composed of f of x, or g composed of f of negative 3. That's goth instead, right? So it can be written as g-o-f or g parentheses f of negative 3, right? Okay. Either way, that means composition. So we're going to plug negative 3 in where first?
Square. 3 times
We're going to do the f first. So negative 3 squared plus 2 times negative 3.
No, it's minus Joe.
This is going to be 9 minus 6, which is 3. Now what?
Negative 1. I'll put it back in.
G of 3 is going to be 3 minus 4, which is negative 1. Yep. So notice here I do not have 2 answers. 3 is not my answer. Only negative 1 is my answer. Got it?
Yes.
But you had to get to 3 in order to get to negative 1, right? Got it? Okay, C is 0. Where's 0 going in first? This is the same thing as writing parentheses, right? That's what he means. So if you see F composed of G or whatever, that's what he looks like, okay? 0 goes into G first, okay? Woo.
Negative 4.
0 minus 4 is negative 4. Now we do, F of negative 4.
This is the easiest garbage.
This is the easiest garbage? See, you were just complaining, and I just, you know.
No, I was complaining about Trig as a whole.
Oh, trig as a whole, you're right. Okay. We haven't even gotten a trig yet.
Good.
16 minus 8 is
Minus 8.
8.
Oh.
Oh, Jose. Oh,
I'm
Jose.
sorry. I'm sorry.
Okay, last one. You want to try this one on your own?
Yeah.
Sure, do it real quick.
Gosh dang it, I don't want
You do it on your paper, I'll do it on the board, and then you can check with me.
I already got it done.
Nice.
She handed the flower.
See, as of late, Trig has been not that bad. Oh, like
Yeah.
you said, we haven't even gotten into
We haven't even gotten a trig.
31. 10 plus 0.5% is 30. What, you don't have it? 11? What?
Why are you reaching me back? Why are you reaching me back, Eva? Something going on in there?
All right, did you get 31?
Yes.
No? Did you get 35 as your F of 5? No. What'd you get,
On our way back to the queue.
Aubrey?
Sure. All of that.
Did you figure out where you went wrong? Yeah? Okay. Good, good? Are we ready to move on to the next one, or are we going to pause? Pause? Okay.
Do it.
Oh, my heaven's sakes. We are unsafe.
I don't like the weather, but I like the activity.
What?
Making Christmas cookies.
Maybe.
Winter is
Probably.
arguably the best season purely because
Winter?
But winter is also good because no matter how cold you are, you can just put on more layers.
That's true.
All right, are we good? Are we ready?
Peel on your skin.
Okay, example 7. We're getting a little bit harder now.
Fun fact, no major.
Example 7, here are my 2 functions, f of x, g of x. Got it?
Meaning
We need to stop. It's 35 already.
What? What are you talking about?
35.
What?
We gotta get 42.
Hypothermia might be enough. And if they're in a
What are you talking about?
4.5
Oh.
dehydration for
Your problems, you mean?
60,
No,
they're
our
probably not dehydration
time.
first. It's not
Is that
good.
Time, we're not at 35, it's 20
Skin
after.
keeps all your moisture. Skin keeps all your water.
I thought we were talking about time. Ellie, what are
Other
you
than that,
talking
it's just
about?
gonna go
Let's
everywhere.
go.
Oh, it's 41, she says. No, that's not what she said? Okay, whatever. All right, here we go. F composed of G. All right, here we go. When we don't have a number, when it's just X.
have,
What do we do with that?
the other.
We don't have a number.
Well, I guess we're just gonna move to minus 6.
X composed of g of x. So we're taking this whole unit, g of x, this whole thing right here is getting plugged into the f part, right? So this whole function is getting plugged in over here where?
But if we were this.
Into the x.
Into the x. So instead of it being 2x minus 6,
Sorry.
this junk goes in the center.
Can we just leave it like that?
You see how that works? We're going to fix one thing. Okay? Do you see how what I just did? The whole g of x goes into f, right? The whole g of x. Okay? So what I'm going to do is this is 2 over 1. I'm just going to multiply him through. So 2 times 1 is 2. And then 1 times that on the bottom is that on the bottom. And then I'm going to leave him from there. I'm not going to do anything else. Okay? I made him into a fraction. I multiplied the tops together and the bottoms together. And then the minus 6 is just hanging on. Okay? That's what he looks like. Got it? So, everybody listen to this really quick. When you plug a number in, your answer is a number. Right? We got numbers up above. If you have an x that you're plugging in, or like you're leaving it as an x, you're going to have an expression. You're going to have x's in your answer, right? If you're plugging a number in, you're going to get a number as your answer. If you have x's there, you're going to have an x in your answer, right? Does that make sense? Okay, so this one, g composed of f of x. Now we're doing it reverse, and we're going to take f of x and plug it in here into the g of x, right? So instead of 1 over x plus 4,
2x minus 6 plus 4.
2x minus 6 is going in that spot.
2x minus 2.
2x, just wait, just wait.
She's leaving without you.
She's taking off without us. Okay, now we simplify. We simplify negative 6 plus 4,
I was wondering
I
was like,
and there he is. Okay, we just combined the 6 and the 4. Got it? Questions about that?
you're going move speed.
Yeah.
Woo, we're going super fast. Super fast. Okay?
Wait.
All right, one more. Example 8.
We did that example, Matt.
We're doing this example. Example 8.
Like, wait, what did you get?
I wasn't paying attention.
This is nasty.
Okay, are you ready?
Uh-uh.
Here we go. We're talking domain. All right, ready? They want us to do M composed of P. So which one goes inside? P does. P goes inside of like this part right here. He goes there. Ugh, that's disgusting. Okay, so 1 over
No.
the square root, this 1 over x minus 5, and now it's the square root of x minus 2. Let me do that better. Let me do that better. 1 over x minus 5, and this stuff goes inside of there. X minus 2. Can you combine the minus 2 and the minus 5?
No.
No, ma'am. All right, so that is what he looks like. He's done. Now we have to find the domain. Are you ready? We have to find the domain of that thing. Ugh. What do we have to worry about with domain?
It being 0.
A negative inside of square root or division by 0, which I think I did division by 0 first. It doesn't matter. A negative inside square root. Okay, which one do we have going on? We have both of them. Yuck.
You know, it
Yeah.
can't. Stop.
Okay.
Go out and we gotta go out. So I
It can't be 27.
Okay, x can't be.
Okay, let's deal with this stuff first. If I'm doing the square root of x minus 2,
It can't be 2.
So it has to be greater than.
it can't be less than 2, right? Like if it's 1, 1 minus 2 is negative. That's not going to work, right? What if it's 2 exactly?
It's 0.
It's 0. Can you take the square root of 0? Sure you can. What about 3?
X is greater than or equal to.
Okay, according to this one, x has to be greater than or equal to 2. Does that make sense?
According to the other one.
Yeah? Now, according to this, we have to look at the whole bottom right here, right? I want to make sure that the whole bottom, the square root of x minus 2 minus 5, can't be what?
5.
That whole thing can't be 0. The whole bottom can't be 0, right? I don't want that bottom part to be 0.
Still 27.
Okay, now what?
Take the 5 over, square it, minus.
Add the 5, add the 5. So the square root of x minus 2 is not equal to 5, and then we square it.
Square root of x minus.
X minus 2 can't be 25, and then we add the 2 over.
There you go.
So x can't be 27. Okay, now I want to combine the 2. We know that x has to be greater than 2, but
Can't be 27.
x can't be 27, right?
Union, right?
Yeah, so what we have going on here is, here's the number 2. And I have greater than or equal to 2. But then at 27, I have an open circle. Right? I want to write this in interval notation. So it can be a number is bigger than 2, but I can't have 27 exactly. So what's this little piece right here look like in interval notation?
2.
Bracket 2, 27 paren, unioned with
27.
paren 27 to infinity paren. Do you see how that works? This junk versus that junk. So the two little yellow pieces. This is 2 to 27. This is 27 and beyond. Union those two together, right? Do you see how that works? Yeah? Oh, heavens to Betsy. Okay, that's a lot. That's a lot of stuff. All right, we are to, I don't know how far we got. Compose and decompose functions.